Hello everyone. Today I'm going to be showing you how to use the half-life formula. Now, this is the formula right here. A equals original amount times 1/2 to the power of t divided by t. Now, if you look at this, you see I have written 1/2. And that just represents that this amount of time, is your half-life. So it's just half-life. And then the upper one is the time that has gone by. And then this is just your original amount. And then A is your amount remaining. So, let's use an example of this. So let's say your half-life. So your half-life, let's use carbon 14, which is used for carbon dating. And the half-life of carbon 14 is 5,730 years. Alright, well, let's say we have 100-gram samples. So 100 grams of original sample. And then let's say 17,190 years go by. How much do we have left? Well, we can use the formula to figure this out. So we have A is equal to 100 multiplied by 1/2 to the power of 17,190 divided by 5,730. Now, using order of operations, you get A is equivalent to 100 multiplied by 1/2. You could also write it as 0.5, but I'm just going to be writing it like this. Anyway, yeah, so this just equates to 3. And then 1/2 to the power of 3 is 1/8. Multiply that by 100. And you get 12.5. And that would be grams, and that's your amount remaining. Alright, well, chances are you're not going to be able to know how many years has gone by. Well, let's figure that out. So, we're going to use actually the same amount of variables, but we're going to solve it a different way. But we're going to know a different thing, alright? We're going to actually know the amount remaining, which is 12.5 grams. But we're actually in the equation just going to write it as 12.5. And then equivalent to 100 times 1/2 to the power of x divided by 5,730. So we're going to be solving for how much time has gone by. Now, it's not a normal way to solve it because of the fact that it's an exponent. So to use this, we must use logs. But before that, we need to get rid of this 100. So we divide by 100. Ooh, that was bad. And then divide by 100. And we get 0.125. Alright. And we're going to use logs. So log, oh my gosh, that was bad. Log of that over log of 0.5. And that is just the half. So we're getting rid of that. Oh, sorry, that was out of everything, so that didn't make sense. Yeah, this is an O. I just can't spell today. Anyway, so when you do this, you get 3. And then that would be equal to, since you got rid of all of this stuff with the log and then divide, you just have this. Now, you can't have it where it's 0 to the power of x divided by 5,730. You can't. You just can't. Well, I could rewrite it as that so it makes more sense. And then, so we're actually, it's going to be written as x divided by 5,730 years. And then you just multiply by 5,730 on both sides to get x is equal to 17,190 years. So this is how you use this very simple formula right here to figure out half-life. It starts to make a lot more sense when you use this. Alright, thank you all for watching. Have a nice day.